Okay, so now I'm going to tackle the next Codility lesson. It's called Genomic Range Query and it's in the Prefix Sums section. So let's get straight into it. I've got 120 minutes to do this. So let's have a look at the description. Okay, a DNA sequence can be represented as a string consisting of the letters A, C, G and T, which correspond to the types of successive nucleotides in the sequence. Each nucleotide has an impact factor, which is an integer. Nucleotides of type A, C, G, and T have impact factors of 1, 2, 3, and 4, respectively. You're going to answer several queries of the form: what is the minimal impact factor of nucleotides contained in a particular part of the given DNA sequence? The DNA sequence is given as a non-empty string S consisting of n characters. There are m queries given in non-empty arrays P and Q, each consisting of m integers. The kth query requires you to find the minimal impact factor of the nucleotides contained in the DNA sequence between positions PK and QK inclusive. For example, if we have the DNA string CAGCCTA and arrays P and Q such that P is 250 and Q is 456, the answers to these three queries are as follows. The part of the DNA sequence between position 2 and 4, which is P0 and Q0, contain nucleotides G and C twice. So 2 and 4. So this is position 2, 3, 4, whose impact factors are 3 and 2 respectively, because G is 3 and C is 2. So the answer is 2. Okay, the part between the next query 5 and 5 contains just T, whose impact factor is 4, so the answer is 4. And the part between 0 and 6, which is the whole string, contain all nucleotides, and A, whose impact factor is 1, so the answer is 1. Okay, so we're trying to find the minimum out of A, G, C and T, with A being 1, C2, G3 and T4. The minimum nucleotide value in the range of these. Presumably we're going to return an array. Yeah. So write this function that, given the non-empty string S consisting of n characters and two non-empty arrays P and Q consisting of m integers, returns an array consisting of m integers, specifying the consecutive answers to all the queries. So in the case given here, 245506, the answer is 241 as described above. So let's have a look at some limits. We need to write an efficient algorithm where n, which is the length of the DNA string, is in the range of 1 to 100,000. M is an integer within the range of 1 to 50,000. And each element of P and Q is in the range of 0 to n minus 1. In other words, the queries are all sensible ranges. They're not going to go outside of the limits of the string. P is always less than or equal to Q, so we don't need to worry about the minimum and maximum values. And string S consists of only the uppercase letters A, G, A, C, G and T. So let's have a look at this in Eclipse. So I've prepared a class. I just need to add the solution method, and I'm going to copy and paste in the example. So the string is here. So okay, so there I'm just calling the solution method with the string in the example and the P and Q array in the example. Now the thing that I think this is a respectable exercise, and we want an efficient algorithm. So I think the trick here is that we're going to do m queries on this string, and m can be in the range of 1 to 50,000. So I think what we may be tempted to do is to take the values between p and q. They're the start and end indexes to look at through the string, and then loop from the index. So for example, from P2 and Q4, if we start at position 2 and loop from 2, 3, 4, and think about the values in the of the values of these nucleotides as we go through, and then take the minimum value after we finish the loop, take the minimum value and add it to the result array. That's going to be pretty slow if we're doing 50,000 queries. So I think what we need to do is populate some arrays with counts of these things. It is in the prefix sums section, so I think we need to do some pre-processing of the data and then do queries on that much quicker. So what I'm going to do is I'm going to set up an array for each of the strings A, C, G and T. So the array is going to be a 2D array. The first dimension of it will be A, G, C and T, and the second dimension of it, as I work through the string, I'll total up the number of these characters that I see. So what I mean is for A, at position 0 I've seen 0 of them, at position 1 I've seen 1 of them, then 1 of them, 1 of them, 1 of them, 1 of them, and 2 of them. And then I can look in that array at any two positions, and if the value between them has changed, I know that there is a nucleotide within that range. So I can quickly check with two indexes to see if there's an A in that range somewhere. So let's have a go at that. So I'm going to make a 2D array. Counters. And this is going to be one for A, G, C, G and T. And they're going to be in that order because as I'm going to loop through this array, if I can see that there's an A in the string within the two ranges, within the range, then I know that that is the minimum value. I don't need to look at C's, G's and T's. Actually, I never need to look at T's, because if we don't see an A, C or G, it did say in the description that the string would only contain the characters A, G, C and T. So if we don't see an A, C or G, we know that the answer is 4, because it must be all T's. Okay. And the other dimension of the array is the length of the string. So now I'm going to loop through the string. So this will initialize with all zeros. I'm going to loop through the string one character at a time. So this is the index of the string. and the character is going to be substring I and I plus 1, and then if C, I'm going to have a counter for each A, C and G. We're not going to worry about T. I'm going to start them off at 0. Say if CH equals A, then we count that A. Else if CH equals C, then we'll count the C. And if CH equals G, we'll count the G. And then in our counters array, at index I, position 0, index I, we'll put in A, and we'll do the same for the others. So we should have an array now. The first row of it is going to count the A's, so it's going to be 0, 1, 1, 1, 1, 1, 2. The second row of the array will count the C's, so this would be 1, 1, 1, 2, 3, 3, 3. And the third row will count the G's, so this would be 0, 0, 1, 1, 1, 1, 1. Okay, we don't care about T's. If we don't find an answer, then the answer is 4. Okay, so let's pull that down. Okay, so now I'm going to create my result array, and that is going to be at the length of M, which is the length of P and Q. We know P and Q are the same length. So I'm just going to make it P length. And then we're going to loop through. The index now is going to be the index of the query. So I, because no I is less than result length I plus plus. Now, if so, start index of the query equals P I, and its end index of the query is QI. Now, actually, this array up here, I think I need to start off at 0. Let me just think. If we're given 0, 0 as a result, I need the start index to be -1. Rather, I need the end index to be +1. I'm just thinking, if I'm given the same value for the start and end index, I can't just look at the number. I need to look at the previous point. So I need to make the length of the array +1. And I need the first position of the array to be initialized with 0, 0, 0. And then loop through from position 1 to the string length +1. rather to the string length. So the first value of the array is initialized to 0. I think that's right. And then if the counters 0, so this is the A array, start index not equal to, it will be less than, but end index, then the result is 1. So initialize the result to 4. Might as well do this with another loop. J is this 3, J plus plus. So I'm going to loop from A, C, and G. And if the counter at that position from the start index to the end index is not equal, then result equals J plus 1, because A is 1, C is 2, and G is 3, but the index of the array is 0, 1, and 2. And break out of the loop once we have the result. I'm just going to call that R because the array is called result, and then result at position I equals R. Now I've done quite a bit there without testing, so I'm going to have to test to see. I'm going to debug through to see if that works, and then I'll have a think about some corner cases if that works. First I'll just run it and see if it works. So exception string index out of bounds. Well, I'm going to want to debug through this anyway, so I shall debug. Okay, so counters, we have three rows, and the length of this is 1, 2, 3, 4, 5, 6, 7, 8, and the string is 7 long, so that's right. Okay, so we're going to look at the first character in the string, which is going to be C, and we're going to add, oh, the first character of the string is A. Okay, so I'm looping. I don't want to be doing that. I'll loop through the string like that, but add 1 onto the index when I put the counter value into the array. So just debug through again. So the first character is a C. We add 1 onto C, and then we put those values in the array. So now we can see the A array has got a list of zeros, the C array has got a 1 in the position 1, and the G array is empty. Next character is an A, and the counters, we have 1 in A, we still have 1 in C, and we have 0 in G. Next character was a G. No, it was a, yeah, it was a G. So that's right, and now that's right. And I'll just go through to the end. I trust it's working. Look at counters array, CAGCCTA. So there's the first A and the second A. There's the first C, 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 and we just see 1 G, and we don't care about T's. Right, so that looks right. Okay, so result. We make the result 3 queries, so we have 3 results. The first query goes from 2 to 4, 2 to 5. Right, okay, I think that's right. We'll assume the answer is 4. We'll see if there's an A in that range, which there isn't. Is there a C in the range? There is. So the result equals 2. Break out of the for loop, and that's our answer for that query. The next one is 5 to 5, so that's 1, 2, 3, 4, 5. Start index is 5, end index is 6. We'll assume it's 4 and we'll miss all of these. So the result is 4. And the next one is 0 to 6. This is kind of a corner case, I would say. It's testing. It's going to look at the whole array. And we've got an A in there. Break out the loop. The answer is A. 2, 4, 1. So that's the result we wanted. I think that is everything. I'm just going to look at the description. So n is an integer within it. It doesn't matter about the size of the string. We've tested the corner case of going right from the start to the end. That was kind of included in the example. So that should be okay. The length that it's going to take to do this, the initialization is going to take, in big O notation, I think it's going to be n plus m. But that's going to be okay. M in the integer in the range of 1 to 50,000. That's kind of why we're doing this this initialization calculation first, so we only need to do the count on a string once, and queries are going to be very fast. Each element, well, we know that this is all sensible values, and this is an important one, that the string only contains A, C, G, and T. So if we don't see A, C, and G, we know the answer is T. So I think that's everything. And I think the corner cases, we've tried just one character. We've tried right from the start to the end. So I think that's our answer. And I'm going to submit it and see how it does. So just run the tests. Compilation successful. Correct answer on the example case. And the code is syntactically correct, but is it efficient enough? I think it is. Are there any corner cases that might trip it up? I don't think so. So let's submit and see how we do. So it's taken 25 minutes. And 100%. Right, so it was a respectable task, and I think that is just because we're not going to want to be taking each query in isolation and looping through the string from the start index to the end index and seeing and comparing, doing an equals call on the string to see if it's a C, an A, or a G, or I think that would just have been too slow. So it's 100%. I'm happy with that. Let's have a look at what the corner cases were. All the same letter. Yeah, that wouldn't have tripped us up. Large random strings, extreme large, all max ranges. Yes, we've given it 100,000 length string and 50,000 queries. that would have been too slow if we were looking through. And there's the big O notation, n plus m, so it was n to set up that initial 2D array and then m to query it. So I'm happy with that 100%. So if you've got any other ideas, then leave it in the comments, but thanks for watching.